This is Leetcode in under a minute. We're doing the grind 75. The first one is two-sum. This one's pretty easy. We get a list of numbers and a target, and we want to turn the two indices in the array that add up to the target. The obvious answer is to do an n square solution, but let's do O of n. But let's create a mapping. We're going to hold the indices of the other values. We're going to enumerate over the numbers. We're going to add that to the mapping. Now we're going to enumerate over the numbers. Check if the target is in the mapping. If the index is not the mapping of the target minus n, then we return the index with the mapping target minus n. Otherwise, we return an empty array. Cool. Looks like we passed all three cases. Submit it. We passed. Awesome. So this is Leetcode in under a minute. This is best time to buy and sell stock. The second question in the grind 75. So this question is trying to find the maximum profit between two price points in an array of prices. So you get an array 7, 1, 5, 2, 3, 6, 4, and then the maximum profit is 5. So basically you're trying to find the maximum and the minimum, but the only edge case is that when you set a new minimum, you want to reset the maximum as well. So let's go ahead and do this. I create a min val, a max val, then we iterate through the prices. We also create a max profit, the min of the price, and the min val, and then we reset the max val. And then we return the max of the profit at the very end. Cool, that works. This is Leetcode in under a minute, episode 3. We're doing valid parentheses in the grind 75. So given a string S that contains the parentheses of these, determine if the input string is valid. Input string is valid if an open bracket is closed by the bracket of the same type. Open bracket must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. So we can use a stack for this problem. So let's go ahead and create a stack. And then let's create the open parentheses. So now we can iterate through the string. If we see an open parentheses, we can add it to the stack. Otherwise, we need to check if the stack is not empty. And then we want to get the last character. So now we want to check if the parentheses match up. And if it does, we want to pop off the stack. And we want to repeat this for all the different parentheses. And last but not least, the curly bracket. Otherwise, it's not valid. And then at the very end, we want to return that the stack is empty. So let's run this. Cool, it passes the cases. Let's submit it. That worked. Awesome. This is episode 4 of Leetcode in under a minute. We're doing the grind 75, and we're doing merge two sorted linked lists. You're given the head of two sorted linked lists, list 1, list 2, and the numbers are this, and we have to return one sorted linked list. So let's get started. This is this classic pointers question. So we're going to create a sentinel node, and then we're going to keep the pointer to this new head. Now, we're going to iterate until both of the lists are empty. List 1 is empty, that means list 2 has an element, and we're going to put it onto the new list and move the entire pointer array forward. And then we're going to repeat this if list 1 is less than list 2, because we want to insert this in order. And then we're going to return the head.next because we have a sentinel node. In these cases, let's try it. That works. This is Leetcode in under a minute. We're doing the grind 75, and this is valid palindrome. So a phrase of the palindrome if it converts all uppercase letters into lowercase letters and removes all non-alphanumeric characters, and it reads the same forward and backwards. So return true if it's a palindrome, and false if it's not. So a man, a plane, a canal, a Panama is true because when you remove the lowercase and the punctuation, it becomes a palindrome. So let's get started. Here we need some regex probably. And we're going to find the midpoint, and then we're going to lower it, and we're going to strip all the punctuation. So we're going to enumerate through S. And if the index is greater than the midpoint, we're just going to break. And if the character that we're looking at is not the same as the end character, then we're going to return false. and then at the very end, we return true. So just check with the regex. Cool, that works. This is Leetcode in under a minute. This is episode 6, and we're doing invert a binary tree. So given the root of a binary tree, invert the tree and return its root. So inverting just means flipping the nodes from the left one to the right one, and it's a binary tree, so you know every node has 2 children. So let's get started. We're going to need to recursively traverse the tree. So let's call on root.left, and then call invert tree on root.right. And then these are pointers, so we can just swap the children, and let's hold temp and swap the children, and then set to temp, and then return the root, and then we need a null check to see if root is none, then return the roots. So let's run this. Looks like it passes. Let's submit it. Cool, that works. Welcome back to another episode of Leetcode in under a minute. This is episode 7, and we're doing valid anagrams. So given 2 strings s and t, return true if t is an anagram of s and false otherwise. So an anagram is a word or phrase that can be made rearranging letters of a different word or phrase. So anagram is same as nanagram, which is basically the same letters. Let's get started with a classic dictionary problem. So we need a dictionary for both s and t. So we can go ahead and do that. And we're going to just use a default dict because that makes this problem a lot simpler to code. So we're going to use collections, and then we're going to create collections.default dict, and this 0. And then basically every word that doesn't exist already is going to be set to 0 in the default dicts. So we're going to iterate through the characters in S, and then I'm just going to add 1, and then we're going to iterate through the characters in T, and then add 1, and then we're going to return if S dict is equal to T dict. Both cases pass, submit it. Cool, that worked. Welcome back to Leetcode in under a minute. This is episode 8, and we're doing the ground 75. This is binary search. So given an array of integers num that's sorted in ascending order, write a function that searches for the target. Otherwise, return -1 if the target does not exist. And this algorithm must run in O log n runtime complexity. So in this array, we're searching for 9, which is index 4. And then in this array, we're searching for a target 2, which does not exist. So we return -1. So this question, let's get started. I prefer to do recursively because recursive is just easier. And we create a helper function for this. And then we set a case which start equals n, return -1. Otherwise, we find the midpoint, which is the start plus n as an integer. And then if the nums of midpoint is equal to the target, then return the midpoint. Otherwise, if the target is greater than the nums midpoint, then we return the upper side of this binary search. Otherwise, return the lower end of the binary search. And then we need to set the midpoint plus 1 in order to iterate to the upper end of the binary search. And then we just pass in parameters, and let's try to run this. Looks like pass the test case to submit. Cool, that works. Welcome back to Leetcode in under a minute. This is episode 9 now, and we're doing flood fill. So given an image represented by a 2-dimensional array and a starting coordinate, we want to fill all the adjacent coordinates that have the same number as the initial, and we want to return the image that is changed. So we get a starting coordinate and a 2-dimensional array, and then we want to fill it with that color. So this is a classic DFS question, and let's get started. So we need to import a queue, and I'm doing this in Python 3 because they already have a queue implemented. So let's import the queue and then create the queue, and then put the starting coordinate. So get a reference to the initial color, because we're going to change that, and then keep a visit set. And then while the queue size is greater than 0, we want to put the top of the queue. And then if queue x is greater than the boundaries of the image, we want to continue. Otherwise, x is less than the boundaries, we want to continue too. And then if the fill equals the image x and x, y is visited, we want to add this here into the visited set. And then otherwise, we want to fill it and then insert the new coordinates onto the queue. And then we want to return the image at the very end. So let's run this. Looks like that worked, and let's submit it. Cool, that worked. So welcome back to Leetcode in under a minute. This is the grind 75. In episode 9, we're doing the lowest common ancestor of a binary tree. So given a binary search tree, find the lowest common ancestor of a node given 2 nodes in the BST. So in this example, we're given node 2 and 8, and then we want to find the lowest common ancestor, which is 6, because 2 and 8 are children of 6, and there's nothing lower that has both of those children. So let's go ahead and get started. This is a classic recursion problem. So we're going to create a helper function to do the recursion for us, and we're going to call it contain LMs. And then we're going to pass in the root in the LM. So we have a couple boundary cases, which is if the root is false and if the root val is equal to the let val, return true. And then we want to do the recursion. So this can actually be made into a DP problem because there's a lot of recurring subproblems, and we can cache the results of them. But for the sake of time, we're just going to make this a regular recursion problem. But we can get some significant speed improvements if we made this DP. So we're going to recurse down the left and right subtree, and then if either one of those contains LM, then that means that is that contains LM and our function return true. So now we can write the main lowest common ancestor function, and we need to do a boundary case. And then we want to do a DFS because we want to go lowest first, so we want to put the recursion in the front, and we want to recurse down the left, and then we also want to recurse down the right. And then if the lowest exists, that means we can return it, and because it went to the function, otherwise it would be none. And then we can go into, we can check the root if this is a lowest common ancestor, because sometimes that is the case. And then if the root is the lowest, then we just return the root. So let's try run this. Pass to the test cases. Let's try submit it. Cool, that works.